So today we will see Vertex AI. So let's see the overview. In this lab, we will use BigQuery for data processing and exploratory data analysis, and the Vertex AI platform to train and deploy a custom TensorFlow regression model to predict customer lifeline value. So the goal of the lab is to introduce to Vertex AI through a high value real world use case, predictive CLW, and we can start with a local BigQuery and TensorFlow workflow that you may already be familiar with, and progress towards training and deploying your model in the cloud with Vertex AI. So this is the diagram of the Vertex AI. Okay, it consists of auto ML, then there is experimental model, train and deploy, and there is this model monitoring, explainable AI, feature store, ML metadata, then pipeline and notebooks. And in this stage, no code slash low code workflow will be there, and in this stage custom training workflow will be there. So Vertex AI is a Google Cloud next generation unified platform for machine learning development, and the successor to AI platform announced at Google input slash output in May 2021. So by deploying machine learning solution on Vertex AI, you can leverage the latest ML pre-built component and AutoML to significantly enhance development productivity. The ability to scale your workflow and decision making with your data and accelerate time to value. So now let's see the objective. So in this lab we will learn train a TensorFlow model locally in hosted Vertex notebook, then create a managed tabular dataset artifact for experiment tracking, then containerize your training code with cloud build and push it to Google Cloud Artifact Registry. Then run a Vertex AI custom training job with your custom model container. Use Vertex TensorBoard to visualize model performance. Deploy your trained model to a Vertex online prediction endpoint for serving prediction. Then request an online prediction and explanation and see the response. So now we will set up the lab. So for setup we will click on the start lab. Now click on the open Google Cloud console. It will automatically enter the username. Click on next. Now we will enter the password. Click on I understand. Agree the terms and condition. Okay, so now our lab is set up. Now we will activate the cloud shell. So this is our cloud shell. Click on continue. Let me change the text size. We'll check the active account name with this command. Okay, So this is our active account. Now we will check the list of the project ID. Okay, so this is our project ID. So first task is we will enable the Google Cloud services. So for enabling the Google Cloud services, we need to use the gcloud command in the lab. Okay, so we will use this. Now second task is create Vertex AI custom service account for Vertex transport integration. Okay, so here we will first create custom service account. So it's done now. Now second is we will grant it access to cloud storage for writing and retrieving TensorFlow logs. Okay, it's done. Now we will grant it access to your BigQuery data source to read data into your TensorFlow model. Okay, it's done. Now we will grant it access to Vertex AI for running model training, deployment and explanation jobs. Now the next task is launch the Vertex AI workbench notebook. Okay, so to create and launch a Vertex AI workbench notebook, we need to navigate to Vertex AI and select the workbench. Okay, so this is our Vertex AI. And this is our workbench. So on the workbench page, click enable notebook API. Okay, it's already enabled for us. Okay, then click on user manage notebook tab and click create new. Okay, so this is our create new. So we need to name the notebook. Okay, and select the region US Central 1 and zone US Central 1B. Okay, so this is our instance. So we'll check. So it's US Central 1 and it's US Central 1B. Okay, now in the new instance menu, we will choose latest version of TensorFlow Enterprise 2.11 in environment. Okay, it's already there, 2.11. Now we'll click on the advanced option to edit the instance properties. Now so here we will click on the machine type and select E2 standard 2 for machine type. So it's E2 standard 2. Okay, E2 standard 2. Then leave the remaining field at their default and click create. So after a few minutes, workbench page list your instance and followed by open Jupyter Lab. Okay. Okay, it's done. Now we will click on open Jupyter Lab. Okay, it's open now. Okay, now we will check our progress. Okay, awesome, it's completed. Now the fourth task is clone the lab repository. So next we will clone the training data analyst repo to our Jupyter Lab instance. To clone the training data analyst repository in our Jupyter Lab instance, we need to go to terminal icon and open a new terminal. Okay, so in this image we need to go here and open this terminal. Okay, so we will click here. So this is our terminal. So at the command line prompt we will type the following command and press enter. Okay, so here we are cloning the repository. Click enter. Cloning is in progress. Okay, it's done now. You can see here, this is our training data. Okay, this is our training data analyst repository. Okay, it's done. We have successfully cloned and we can see the folder content. Okay, so this is our folder content. Okay, now we will check the progress. It's done. Awesome. Next we will install lab dependency. Okay, so we will run the following. Okay, we need to do this. Enter Y. Okay, it's done. Now we will navigate to lab notebook. Okay, so we will open the lab exercise. Okay, this is our file. Okay, now in this we need to continue the lab in the notebook and run each cell by clicking the run icon at the top of the screen. Okay, or alternatively you can execute the code in the cell with shift plus enter. Okay, so let's see. Okay, so here we need to execute this one by one. Okay, okay, so I'm at this first cell. Okay, and now I will click this run option. Okay, it's done. Environment are set. Okay, now we will retrieve and set the project id. Okay, and region environment variable. Okay, it's done. Okay, now so here if you see the number, it's showing first for the first cell, second for the second cell. It means the execution is completed. Okay, now third is create a globally unique Google Cloud storage bucket for an for artifact storage. Okay, it's done. Now we will use this command. It's still executing, so now it's completed. So it's created the bucket. Okay, now we will import the libraries. Okay, so this all are our libraries. Okay, it's done. Now we will initialize the Vertex Python SDK client. Okay, so for this import the Vertex SDK for Python into your Python environment and initialize it. Okay, let me scroll down. Okay, so now we will download and process the lab data into BigQuery. Okay, now we will do the data injection. Okay, so this Python script will take about 2 to 3 minutes to download and process the lab data file. Okay, following along with logging output in the cell below. Okay, it's done. Now we can see it's outputted. Okay, now we will do the data processing. It's exploratory data analysis in BigQuery. Okay, so this query is for how recently have customer purchase. Okay, okay, so this is the job id and it's downloaded. Now we will describe it. Okay, okay, this is the day since last purchase. So this is the uh, customer purchase. Okay, this is the chart. Now we will go through frequency, how often are customer purchasing. Now we will describe. So this is the output for how often customer purchasing. Okay, now we will see the graph. So this is the graph. Okay, now next monitoring how much our customer spending. Okay, so this is the output and this is the graph. Now next we will establish a simple model performance baseline. Okay, it's done. Next, we will look to plot the baseline result to get a sense of opportunity area for our ML model. Okay, it's done. So this is the output. Okay, and this is the graph. Next we will train a TensorFlow model locally. Okay, okay, this is the output. It's completed. Okay, it's done. This is the graph. Okay, okay, this is the graph. And we have trained a model better than the baseline as indicated in the chart above. There is still additional feature engineering and data cleaning opportunity to improve the model performance on the customer with CLV. Okay, so some option include handling this customer as a separate prediction task, applying a log transformation to our target, cleaning their value, or dropping this customer all together to improve the model performance. Okay, congratulations. So in this lab we have ran a machine learning experimentation workflow using Google Cloud BigQuery for data storage and analysis, and Vertex AI machine learning service to train and deploy a TensorFlow model to predict customer lifetime value. And you progressed from training a TensorFlow model locally to training on the cloud with the Vertex AI, and leverage several new unified platform capabilities such as Vertex Tensor Board and prediction feature attribution. Okay, so now we will close this. We will log out from here and we will end the lab. Okay, so thank you for watching, and if you like this video, so please click on the like button, and if you have any question, any suggestions, so please put down your comment in the comment section, and please share this channel with your friends and colleagues. Have a great day. Bye.